Sharp, the House Whisperer, host of Home on KFI with this week's Vodcast Extra. I love giving you little tips that you normally are not going to hear anywhere else. And so this week, I thought I would address a subject that every DIYer has encountered who's ever tried to build something big and keep it square. So what we got going on in this yard right now is a shed is going to be built here day after tomorrow. And to get ready for it, we've laid some 6x6 pressure-treated lumber down as a foundation. So a shed is not a big building by any standard, but it's bigger than most of the stuff you normally work on inside the garage or in the workshop or on top of a countertop. Places where squares like this come in really handy. But when a footprint of a shed like this one is 10 feet in one direction and 12 in the other, how do we keep something like that, or something that's 10 times bigger, truly square? Do we use this? No, forget that. Do we get a bigger square and use one of these, a framing square? No, still not gonna get it done, and I'll tell you why. If there's even the slightest bit of inconsistency in our square against our wood, even a 1/16 of an inch over the course of, let's say, a foot, by the time you multiply that 1/16 of an inch error down 10, 12, 16 feet, we're already an inch out of square. And the bigger the building gets, the worse that mistake becomes. That's unacceptable. So how do builders measure up and square something this large or larger? Well, you've got to get yourself a bigger square. And what does that look like? It looks like this right here. How does this square up a building? We're gonna have to talk about that first inside. To understand this, travel back with me to ancient Greece in the time of a man called Pythagoras, an Ionian Greek philosopher and mathematician who, you probably didn't know, was rocking a really cool lumberjack beard and apparently had very narrow shoulders. Very strange. And here is a painting by the 19th century artist Fyodor Bronnikov, Pythagoreans Celebrate Sunrise, which apparently represents the fact that in ancient Greece, if you were a really cool mathematician, you got to hang out with musicians, and people got really emotional about it. Definitely a different time. But what Pythagoras is famous for is, of course, the right triangle. And that is not that he invented it, but that he figured out how to calculate, based on the length of this side and this side, what the hypotenuse was. Now, that seems kind of abstract and ethereal, but the fact of the matter is it's very important when it comes to finding a building that is square, because of course a right triangle has a 90-degree corner, or in building terms, it is square. Side A, side B, and the hypotenuse is side C, which leads us to his famous theorem, a squared plus b squared equals c squared. Now, you might not think that builders are all that interested in theoretical geometry, and you would probably be right, but builders take math very, very seriously, especially when things get really, really big. And it's what we call the 3, 4, 5. And what does that mean? It just so happens that those three numbers, 3, 4, and 5, precisely represent the features, the A side, the B side, and the C side. What does that mean? It means this. When I go out to a big building corner, I measure down one side 3 feet and I make a mark. I measure down the other side 4 feet and I make a mark. And then if I measure diagonally between those two marks, what do you think I should have? I should have 5 feet. So here we are back at the shed foundation. We're gonna find out if we actually built this thing square, and we're gonna see if the 3, 4, 5 actually works. I'm pulling out of this corner 3 feet. Making a mark. Go into the next corner, opposite direction, 4 feet. Making a mark. Now, the magic. From the far corner over to this one, guess what we have? 5 feet. 3, 4, 5. This corner is square. It's almost as if I've done this before. So the cool thing about the 3, 4, 5 is, as the building gets bigger, as the project gets bigger, your square gets bigger with you. It's a tool that just keeps mathematically expanding. How so? All you do is you take those factors and you multiply them by the same number. So for instance, same corner, same situation, but instead of pulling a 3, 4, 5, I'm going to pull a 6, which is 3 times 2. In the other direction, I'm going to go 8, which is 4 times 2. So now we're measuring our diagonal across, which should be 2 times 5, which is 10. Come here, take a look. Check it out. 10. You see? Our square just got exponentially bigger, and it can become bigger still. It can become infinitely bigger, as big as you need it to get. If you need to take the 3, 4, 5 and multiply it times 3, then you multiply each of those by 3, and a 3, 4, 5 turns into a, 9, 12, 15. If you need to multiply it by 10 on a massive building, then it can simply become 30 feet in this direction, 40 feet in this direction, and a diagonal of 50 feet. You'll use this anytime you go outside the workshop and get away from materials that can be squared by tiny metal squares that you buy at the hardware store. When you get even something this big, 8 by 8, 10 by 10, or larger, you should use a 3, 4, 5 and make sure what you're building is square. All right. Hope you learned something today. Hope it was fun. Make sure to watch the show every Sunday at 10. I'll see you then.